Yeah, all right. So I'm gonna turn that music down just a bit. So yeah, I ended up tweaking that design from the last stream, and so I've got that in place right now. So I've got my phone in that mount with that L bracket on the wall. So off stream, I ended up designing this guy, and that basically has a couple of panhead screws and then screws into that thing. So in terms of that in use, I've got that working now, which is essentially the subject of today's stream. So anyway, for those of you who are new here and haven't seen anything I've done before, I make YouTube tutorials just on how to do basic design things. I've got a side hustle that I recently just quit my job for to focus on full time. So part of what I need to do is design some products to sell. So this stream is me essentially coming up with those products, and then I can teach a cat on the way. And also, it's collab is good. So anybody who's got advice for me, I'm all ears. I eventually will probably end up getting another monitor so that I can actually monitor chats and things like that a little easier. But for now, I'm switching OBS scenes like on one monitor and everything. So I also put a link in the description for Ko-fi or Ko-fi or whatever hell you call it. So I've got a donation link there. Whether or not you feel like doing that, it's your call, but I figured I'd put it out there that it is there. Yeah, it just makes the decision of quitting my full-time job a little bit easier. But yeah, anyway, so I've got that in use right now. So the Caliper Cam is using my phone as a streaming camera. And today what we're gonna do is, well, this is my pedal board, which is essentially just a piece of MDF with some Velcro on it, and then I've got Velcro on the backs of my pedals. So I've been playing guitar since I was like 5 or something like that, and so I've got some pedals strewn about here, and I'm not super happy with it. So what I had in mind today was I actually wanted to design sort of a modular pedal board system. So the main gripes I've got with pedal boards in general is, well, they're pretty pricey all told. So, and the other thing is, you're kind of ended up picking like a form factor to go with, and it doesn't leave a lot of room to like expand. So for example, like this is probably the size of pedal board that I might like to use, based on the number of pedals I've got. Then I've got room to expand a little bit, but I figured if you just had the ability to bolt on another section to your pedal board pretty easily, that would be kind of cool. So I'm mostly designing something that I want, but it could be useful to expand upon later. You know, if you want to go out and add another ledge, that's another thing too. So I'm thinking mainly the main size that I'm looking to go with is something that could hold. So I've got Boss pedals on my pedal board. Those are a pretty good stand-in for a standard pedal board unit. And I want to be able to have like 4 Boss pedals on one. And I like having a 2-tiered system because I can have these lower and these ones higher, so you can tap your foot on like the top part of this without necessarily mashing any of the knobs below it. And we also have the ability to mount a power supply underneath of the second ledge here, so that way we can actually power all the pedals that are on our board. And benefits of the way I want to approach it, which is going to be a 3D printing approach, is I have awesome cable management capabilities because I can make channels that, like, say Velcro or tie wraps could go through in as part of the part that these bars that go across, essentially, is what I'm thinking. So you can have on the underside manage all your cables pretty effectively without using like sticky pads and stuff like that that'll come off eventually. And then also with the two-tiered pedal design, like you see, you've got things like volume pedals that may or may not take up both rows. So instead of having to make the decision right off the bat and then kind of be stuck to a platform that eventually you're gonna either outgrow or it gets too big, you could just bolt on a section that is, meshes with the other pieces, but is like twice as long, so you can have like this sort of configuration. So that's essentially what I'm thinking. Now, to make this viable, like from a product selling standpoint, I mean, I've got to hit a price point, I guess. It's not going to be insanely expensive to produce as far as what I have planned here, but let's just do a little bit of R&D to save ourselves some hassle later. So I'm going to look for... Happy Valentine's Day, everybody. I'm going to look for guitar pedal board, and I'm going to go with Long McQuade because A, I'm in Canada, so the prices are in Canadian dollars that I'm going to be looking at. So we've got Pedal Train Classic Junior board with soft case. So that's $190. Got this nano one. Oh yeah, so that's like you get 4 Boss pedals across, $109 or $110. So we've got it comes with Velcro and tire wraps. That's good. Comes with a case. So the case is obviously something I don't really have a super good plan for. So if that's a selling feature or not, then sure. But this is what, sheet metal welded, like some square tubing that's just like welded together. I'm assuming on the bottom it might actually be sheet metal bent. I don't know if they got any other images of like maybe the back side. Okay, so you're getting 4, 5, 6 pedals on this one board. Yeah, I can't quite tell from looking at it, but it might have like the inside of this section might be hollow. Let's take another look at other things. So we got Pedal Train. Okay, Planet Waves. They've been in the business for a while, and see they're addressing something here where the expandability that I mentioned. Okay, so they've got extruded aluminum channels, and they've got these aluminum end pieces with looks like something like M4 or something hardware that you can take that off. Let's look at the actual description here. So we got patented telescoping design. So it can expand. That's a great idea. So they're addressing the fact that guitar players end up buying pedals and then they get addicted to them, so you can kind of keep going. And we've got, let's see, lightweight, ultra durable, aluminum, withstands most aggressive touring. Okay, so cable management system. Well, what does that look like? Okay, so it looks like they've got these injection molded guys that go across. So yeah, this goes across like this, and then you can weave your cables above and below them, and it looks like they're kind of thinned, so you can kind of just, I'd imagine you just like push the cable down into it. Just one sec, I'm gonna adjust this a little bit. And yeah, okay. So yeah, so they've got these, the top and bottom piece, your pedal expands across that. Now if you've got something like I have, if I go back to this here, so you can see a Boss pedal. I got Velcro on the back of this. I have too much Velcro on the back of this, but I'm just gonna disassemble this for a sec. So what I've got here is, you know, it's got jacks on the sides for your signal path for your instrument, and then we've got a 9-volt connection in the back. So you sort of need to be able to manage the power wiring and the wiring on the side. So the way that they seem to be doing this is they're all the cable management's going in the middle of these two bars that the thing comes across, and then they've got these channels routed out inside. They got rubber feet on the bottom, so this thing does look very sturdy. And in terms of like how this fits, I like that. So I'm guessing that's just like a latching. You pull those out, push it in, and then push them back, and then it's able to like telescope that way. The telescoping feature is not something I'm interested in implementing anyway. Plus, according to them, it's patented, so that makes it trickier. What else we got? So we got Voodoo Lab. They've been in the game for wow. So $500 for a piece of sheet metal with some PEMs in it. Carrying case. Oh, it comes with the power supply too. So yeah, because these guys, I think they got their start making the supplies, and they're kind of like the gold standard, or yeah, they're the vanilla ice cream of pedal board power brick solutions. Yeah, so it's designed specifically for that. And then we've got what? Okay, that's a great feature in the case as well. So it's got Velcro straps to hold that down in the case. So yeah, their case game is gonna... I can't beat them on that, so that's okay. You win. And I'm not into making my own power supply units that would be compatible with mine. So this is an ecosystem that you're buying into at this point, right? I want mine to be as flexible as I can get it. All right, so in general, the cheapest one, so we got 129 bucks. That's a good deal, I think. Provided the bottom of this thing is opened up enough that you can, because it's not obvious to me, and as a buyer who has ADHD, I'm not good with buying things and then they don't work out and then I gotta go return it. I'm looking at Long McQuaid because it'd be fine. I don't mind driving to the store to return it, but I got an e-label, I gotta print it off, I gotta find a box to put it in. Maybe I threw the box out. Just like, the thing that makes me skeptical about this is just, I don't know that it's gonna work the way I want it to, in terms of like having the power squared away. Yeah, and I don't know, in some ways I'm lazy on the research as well. So yeah, so we got this pedal train, this 109. So basically $100. I don't know. So in terms of $100, so $100 to have 6 pedals and potentially room for your power brick. That's what we're looking to beat. I think maybe we can pull that off. We can pull that off for sure with the 2x2, like the tiered Boss pedal thing. I like having the tiered pedal board set up. And my idea of expanding is you're gonna want to expand horizontally first, and then if you want like a third row, then we can think about that as an option later. But it's not something my heart's not set on having that top row as an option. So yeah, that's essentially what I'm gonna get into. So I'm gonna go back into Onshape here. I made a completely blank sketch. So I'm gonna show you what I can do, or how I would go about actually designing this thing. And I've got 3 concurrent viewers. Wow. That's triple the last amount. So anyway, don't be shy. If you want to comment, please. Even if it's bad, even if it's just boo, you suck. It feeds the algorithm. So yeah. So what I think I'm gonna do is I'll start off by doing some mock-ups of some of the pedals that I already have here. So you'll notice I've also got like different form factors of pedals. So we've got these like thin jobbies. So this is, I wouldn't say half, but it's not as tall as a Boss pedal, and I think what it is once you have the cables in, it's about as wide as a single Boss pedal. So let me just double check that, see how that looks. So also, if you're interested in what I think about any of the pedals that are on this board, let me know. So we've got these shitty Donner cables that I bought on Amazon for like nothing. So the Donner cables, they love to stick out, so that sticks out more than a Boss pedal. I mean, granted, the Boss pedal is gonna have this, but let's try one of these. I think this is a Planet Waves one. Yeah, there. No, REAN, whatever that is. So I think I bought these at Long McQuaid a while ago. So that's the width we're talking about here, and it's still about just as wide actually. Okay, I don't know. It's just the look of this it seemed like it didn't stick out nearly as far. So yeah, we've got this. So the main thing I need to worry about is if I straddle something top to bottom. So let's say I got 2 bars going across, something like that, with Velcro on them. I need both this and that to want to work with what's going on there. So I think the best way for me to do this is I'm just going to make a quick mock-up of this pedal and this pedal, just to get an idea of the dimensions that we're dealing with here. And I can add a whammy one later too. I mean, the whammy is so big and ridiculous, but I love it, so that's why it's there. And then the other thing is we sort of need room for the power supplies, and I want that to mount under the second top row. So we can actually get started. I'm going to model I wonder if there's an actual technical definition or common definition of like pedal sizes. Guitar pedal form factors. So let's take a look at that. Stomp boxes. Okay, this is just all pedal effects. Let's see, stomp boxes. Interesting. The content of this seemed good, but yeah, I don't have anything specific. If I'm gonna name the files, I was just gonna say like, if there was a quick and easy way to find the form factor, I'll change it later, but it's no big deal. So yeah, I'm gonna start with the small guy. We're gonna sketch on the top plane here. So the actual pedal itself is drafted. So for just to expedite things a little bit, I'm not gonna really worry about like making it exactly the way it's supposed to look. Sorry, wrong camera. So yeah, like maybe I can show you that. You see how the top of that is thinner than the bottom? So the bottom rectangle is essentially what I'm going to be working with. I'm just going to pretend that it doesn't draft, because these things are like pressed into something. So in order to get them out, they have to have that like angled look to them. And then as far as the boss stuff goes, I mean, that is also like stamped, like the part that you stomp on, and then that is drafted as well. It's a smaller, less noticeable draft, but all of these are going to be modeled as rectangles for the starters. So let's go ahead and try getting this guy going. So I'm going to grab, so I'm going to dimension the edge of this, and I get my calipers out. Okay, 3 point, and I'm going to do it in inches because on my own, I hate what I've become. I used to be a millimeters guy, but I've been using inches for a while doing my professional stuff, so I'm going to keep her in inches. So 3.68. Oops, 3.68 inches this way, and this way is 1.52 inches. Okay, so, and then I'm going to extrude that. So this is just going to be a simple ass rectangle. And what's that going to be? 1.26 inches, let's call it. Alright, so we got that. Another thing too is, I'll switch to the caliper cam again. It's funny, first time I used the calipers, I didn't use the caliper cam. So I've got this. I also got some 3D printed fillet gauges. It's not super important that I have the fillets right on this. I'm here, might as well do it. So, and this is, of course, is a millimeter fillet gauge. So this is, I found it, I can't remember if I got it on printables or whatever. So there's raised letters, or raised numbers on the actual print. If I need to find what the radius of this is, it's between 4 and 5 millimeters. So let's call it 4.5. So I'll switch back to this. So we're gonna go to the fillet tool. I'm gonna find these corners here. There. So I've got that filleted. So that's the Moski Spring Reverb, which is a really cheap pedal on Amazon, and it's actually pretty dope. I wanted a rockabilly kind of sound, just because I don't have I have a reverb built into my amp, but it's not foot switchable, so I want to be able to turn on my surf or rockabilly sound quickly. That's why I'm using that. So now I guess we're going to, I'm going to model in where the actual switches are as well. But for our purposes, I'm going to make them pretty simple. In fact, I think I'm going to make a plane here. So I'm going to make a plane. I'm going to click this front plane, and then I can pick, actually, I'm going to pick this face, and then I'm going to do a plane offset. So what I'm going to quickly do is just measure this on the caliper cam. So this has to be a ballpark. It's not, because where this is kind of going to be different for each one. And of course, remember, this is drafted, right? So it's not, it doesn't have to be a science, but let's call that 1/2 inch to the center, something like that. So if I go back to here, we're gonna go with 1/2 inch, something like that. Why am I doing it on a plane like this? Well, then I can kind of just model the whole shape of this thing for free. So I'm going to sketch on this plane, And I'm going to grab me a line, a construction line. And since I centered that about the origin, this is going to serve fine for an axis of rotation. So the other thing I'm going to do is I'm going to click that line and I'm going to project it. Actually, I'll make that a construction line as well. So then I can just at least like make this coincident. I press the I key and it makes it coincident if I click those two. Let me switch this over. Okay. Because I need a monitor chat in case there's anyone who ever talks ever. So what else? So basically what I'm going to do is the profile of this thing is going to look. So the way we've got this here is I'm just going to do it quickly to get this, and this, and that all figured out in terms of how tall off the board they are. So if I look at this other pedal made by a different company, similar switches, right? So I'm going to do something like that. And then what I'm going to do is just measure how tall off the thing they go. Because I sort of want to know how tall the knobs and the actual stomp switches are. So you can tell they've sourced the switch differently, but so this guy actually protrudes up a little higher. And then this guy's not quite as high, but I'm going to go with the worst case scenario because how high this is might determine where I put another thing later. So I'm going to go with this guy for now. So I'm going to make a line here. I'm going to quickly just figure out the shape of things. So I've got that sort of profile. So what I'm going to be doing is whatever is here, I'm going to end up rotating around this axis, and then that'll make my little stand-in for my switch. So to get the dimensions of this, I'm just going to hit D. Now this is going to be half of whatever I've got here. So I'm just going to measure it off camera here real quick. Okay, so that'd be, nominally that's probably 0.4 inches. So 0.2, that's good. And then I want to measure the height of that, roughly. That's 0.2 nominally. And now the intersection here is about another 0.2. Okay, and now this dimension, I could, my caliper's around that, and I can measure that guy, 3.15. So 3.15 divided by 2. Oh, sorry, 0.315. Whoops. There we go. All right, and then this guy here. .4625. So 0. There we go. And this guy is going to be so we're not going to measure this one because this is the threaded portion, and then there's like a hex nut below it. But from here to here, oops, why is that giving me an angle? Is that not vertical? It is vertical. Is that not horizontal? What is that parallel to? That, okay. And then this one is vertical. So why is that giving me an angle? Let's try this. There. Okay, so 0.3 inches. Okay, there you go. So that's sticking out quite far. And then I'm gonna just put the washer. I'll just do the washer thickness here. So that is gonna be 0.05. And then lastly, this diameter here, which is gonna be, or sorry, this radius here, 0.75. Okay, there we go. So that's how I'm gonna quickly just draw this foot switch. So what I'm gonna do now is I get to go and use the revolve tool. And our revolve axis is gonna be this guy. And there you go. Kaboom, foot switch. So that's a good stand-in for that. Lastly, I'm just gonna model 2 knobs, and these are centered about the middle. So I'm just gonna draw a construction line here, and then I'm gonna draw another construction line here. I like to just put a point here like this. I think there's a midpoint line that I could use instead, but I find this is more reliable. So I'm making that point coincident with this. So now I know that this line, no matter how long it is going to be centered. So the main thing I need to figure out is where is this from, let's say, the edge of the case. And then I can position my 2 knobs from there. So I'm just going to quickly measure that. That's 1/2 inch. Okay, and then lastly, I'm just going to draw the circles here. So we're just going to do basic cylinders for this guy. And then, so I could, actually this is what I'll do. I'll measure this. So the diameter of that, and it's kind of like a hex. Actually, it's actually a 7-sided, 1, 2, 3, 4, 5, 6, 7, yeah, 7-sided knob. There's like little grippy boys in there that you can grab. Okay, 0.5, let's call that 0.6. Okay, and then this circle is going to be equal to the size of that. And then what we can do is I can just measure the distance on the outside of this. I'll show it on the caliper cam because it's probably... So if I go like this and I measure this distance here, 1333. Okay, so 1.34, let's call it. Switch back to this. So I'm gonna go. There you go. So that's our 1.34 distance there, because that's an easy one to measure. Whereas like finding the center point of that is trickier. So that should do for now. I'm gonna extrude that guy. And then the depth of that is going to be 0.625. There we go, something like that. And then, when in Rome, right? Let's just make this pretty. So I'm just going to model that 0.2 because I may repurpose some of this in terms of like doing graphics for like the page and stuff like that. So the closer this looks to a real pedal, the better, I think, for aesthetics. So that's kind of why I'm putting a little bit of like, I mean, this functionally serves no purpose for my stuff, but it makes it look more like a guitar pedal, so that's why I'm doing it. We can do it from a sketch here, and then I'm gonna sketch on there as well, and it's gonna grab a circle and a circle, and these circles I'm gonna click both and hit E to make them equal, and then I'm gonna measure this shaft diameter, let's say 0.2, let's call it 0.3. Okay, and then I'm gonna use those and project them on here, and then extrude. I'm going to remove, and then I want to measure how far up from the top of the case those knobs actually start, and that's 0.2 inches. Let's see, 0.2 inches. Oh, okay. I gotta flip the direction. Yeah, there we go. Here, so we've got those knobs, and then while I'm at it, I can do something pretty quickly on here. I can sketch on this, and we can do a polygon. Is it inscribed that I want? No, I want circumscribed. Yeah. So let's just make, and then I can change the number of sides. So mine had 7. So, and the other thing I want to do here is just make that coincident with there. Make that dot coincident with there. Now we've got 7-sider. And then I'm gonna take the construction line off of that. And then, yeah, I want to duplicate this. So I might as well just draw it. It's not very hard to do that. So I'll do another circumscribed. Oops. Okay, let's try that again. So we got that. And then I want 7 sides. And I'll do a construction line here. Okay, and then we'll make this guy coincident with that. And then I'll turn this construction piece off. And then I can extrude. I'm going to get rid of this as my thing. I'm going to remove it. And I'm just going to click in on these guys here. So, yeah, and then I just need a, wait. Oh, classic. So Onshape is not liking what it's seeing here, because I'm making, oh, wow. So is that circle going to be an issue? Probably. So let's go back into here. So this, when you intersect a circle at a point, in general, Onshape is not super happy when you do things like that, because we all know what I want to do here, but this is like a smooth surface, and it's freaking out because it doesn't know how to close up the form. As far as I can understand, if you know what's going on, you let me know. But I'm just gonna work around the limitation instead of like spending 2 hours researching it. So I'm gonna now just make another center point circle around these. And then that way it's like not gonna be an issue because I'm cutting away all of that. I think. We're going to find out here in a second. So this is what I'm going to try to get around this limitation. So 0. Let's just call it that. And then I can make this equal to that. And then this. Oh, wait. Let's try removing that. Yeah, see, didn't mind that. We're gonna go up to the bottom of this, but we're gonna go offset because it has a little nubbin. And I'll measure that real quick. So 0.08. There we go. There, we got our knobs. So there's our pedal. And so how long did that take? We've been going for... Oh, the stream doesn't actually tell me how long it's been, or at least I can't see it right away. Anyway, it didn't take very long. So we're gonna call this small pedal. FX small, let's call it that. And I'm gonna hide that plane. And then I'm gonna edit the appearance of this. So let's make it purple. There we go. What a beautiful purple pedal. So we've got our mock-up of our object, and then the IRL version looks something like that. At least the face of it. I'm going to actually put the jacks on because that's something I need to be doing. So I'll do that real quick too. Also, between these two, you can see the jack positions are slightly different as well. So this one is up on the top. That one's also up on the top, but just offset from it. So they decided to like wire all their stuff in here, whereas these ones are down in the bottom, because if you were to ask me, I'm guessing that this is a surface mount knob. Also, this knob feels better. Yeah, because so you see the difference between these two knobs. So this one has you know, a nut that goes on here. So you have a split shaft, and so you have a pot back here, and then that secures to the front this way, and then they put the knob on top. This one, probably like a D shaft, and then this fits on over top. But my guess is there's probably a PCB in here that is doing this, because spring reverb versus analog chorus, pretty sure there's a lot more going on with this. Make this compact, they probably, and cheaper, they probably made it a surface mount component that's soldered to a board there. And then, I mean, I could take it apart, but because that's beyond the scope of this stream. But yeah, there's got to be a PCB here. So then they opted to put all the stuff on the bottom here, because that's the only, all this is taken up by the real estate of that circuit board, which probably also has that light on it as well. So I'm just going to quickly put some jacks in place, and then we'll go from there, because the jack spacing is something that I need to think about. So I'm going to sketch on this guy, and we'll go with that. Okay, so I'm going to quickly figure out roughly what that's going to be. So 0.55. Okay. 0.71. 4/6. Okay, and then I'm going to extrude that. That's a really thin. I'm just doing the washer, then I'll do the nut, and then I'll do the jack itself. Something like that. 10 thou. And then we're going to take and make a polygon. Oh, wait. Circumscribed polygon. And then this one is a hex for sure. And then we're going to take this. And then I'm going to just extrude that by the depth of the nut, which is probably... something like that. And then from here, I'm just going to sketch us a circle. I don't know why the projection didn't necessarily work for that, so I'm just going to do a construction line here, and then I'm going to make that be on the midpoint, and then we're going to do that guy real quick. 0.34. Now this thing's threaded as well too, but and also I guess I might as well do a inner one while I'm at it, because then I can make it like this. Okay, and then figure out what that inner diameter is. Oh look, it's a 1/4 inch, go figure. 1/4 inch plus tolerance, 0.252. Let's just make it 0.25. Alright. And I'll extrude that. And that comes up off that nut by... Alright, that works for me. And then I guess what I can do is I can measure one of my cables here, see how far that goes to the tip. 1.21. Sketch on this. Nah, I get that. That's fine. I can make a placeholder cable instead. So yeah, that's where the jack is on one of these guys. So what I think I'm gonna do here is I'm going to use something called split. So I'm gonna split this part, and then I can split with this guy here, and I'm gonna keep both sides of that. So now this is a separate part from that, and then I'm just gonna put this where it needs to go. So I'm going to transform this entity, and I'm going to do it by mate connectors. So a mate connector is an on shape is essentially like you find a piece of geometry that you want. So I want this guy, and then I want him to go like here, let's say, and then I can flip the orientation. And then I want to make sure I'm copying the part because I want that one still there. So I can do that transform now. And then I'm going to take this and I'm going to position this so that it's where it needs to be. So right now it's in the center. I'm pretty damn sure it's in the center here too. Okay, so 0.215 and 0. Okay, so we got 2. Let's call this 2 inches. Yeah, this is not super important, guys, but might as well get it. If I'm gonna take the time to model one of my pedals, I'm gonna model as close as I can. So now what we're gonna do is we're just gonna take this. Actually, I can measure that to here. So I can use show the measurement details here. So this way I can go, I want to look at the, sorry, I don't want this. I want this. Center distance. Okay, so this guy, I'm going to take that number here. So that's how far it is from this edge. And I'm going to make it be 2 from this edge because that's where it is on my pedal. So I can do a transform of this and translate by XYZ. So it's going to be the y-axis. So we're going to do it 2 minus that in inches. Okay, and while I'm at it here too, I'll do the other translation that's required. This is, again, up towards the top. So 0.11. 0.11. So I'm rough. What I'm doing is I'm eyeballing half. I'm setting my 0 point, and then I'm just gonna move it up to the top of that circle. So 0.473. Whoop. Did that not make a difference? Alright, let me try that again. So I've got that as my 0. And there's the center, 0.32. Divided by 2. Yeah, so if I've done that correctly, I should be able to just quickly measure this distance to here. Oops. This distance to here, 0.625. That seems like a valid number. Zero that again. Okay. So that's roughly what we're looking like. Yeah, so we've got our guitar pedal modeled now. So I think what we'll do is make the Boss pedal next. So, but actually before we do that, we're going to merge all these guys back together. So I'm going to perform a Boolean operation. I'm going to grab all of these tools, all these parts, and then put them together. Now that it's all one solid body again, so that it's easy to move this around in an assembly later when I go to do that. So now I have something that I could repeat as many times as I need it, and then I should be able to make the Boss pedal next. So let's quickly model that. I think I'm going to I'm just going to transform this out of the way. I want to make my pedals in One Part Studio, because then I can just import them from that. So I'm going to translate this by distance, and I'll move it in this direction. Let's move this like 4 inches out of the way. Let's do 5. And then I can just close this off. Alright, so I'm going to put my top plane back on. And we're going to make our boss effect pedal. So I'm going to sketch on this guy. Again, we're going to just do rectangles here. So I'll switch back to the caliper cam. So in terms of the boss pedals I have, the jack location is not always the same on all of them because they've got different things going on. So for example, I've got, also I need to change the Velcro job on this guy. One cool thing I picked up from JHS, there's a YouTube channel called JHS Pedals, and they did a video yesterday about build your first pedal board actually, and pro tip they had was on a boss pedal you always have this rubber back. You can actually just take these screws out, flip it around, and put it the other way, so you have a nice, like, essentially like a flat sheet metal back that you can then put Velcro on. For now I like threw it on the inside of this just to get this on here, but I'll switch it around. And apparently you go to hell or a kitten dies every time you put the Velcro that's on your board. You make that, like, never put the soft side on your pedal. I don't know. I know it's a joke, but anyway, I don't know. Maybe I'll just release the whole thing backwards to trigger everybody. But I don't know if that's like a knowledge thing or it's like a tradition or if it was just a meme. But something to think about. Anyway, so we've got these two. You can see the jack location's different on both of them. I got more jacks going on this. So in general, I'm probably just gonna like model it. Seems like the default position is always gonna be here. So I'm gonna end up doing that location, and then any extra jacks I'm not gonna worry about really. So we're gonna very quickly model this. I'm not gonna go crazy with this, but let's get our base dimensions here. So we've got 2.5, let's call it 6. Yeah, let me double check that. 2.56. Okay, and then we've got this one here, 4.73. So let's switch back. Okay, and then I'm going to, what's the best way to do this? I think I'm going to just go straight up the side. So back to the caliper cam. So what I'm thinking is I'm going to model this so that we've got a rectangle that comes straight up to this level. Then I'm going to sketch in this profile, and I'm going to cut, I'm going to basically have a straight line that goes across like this, and I'm going to sketch this profile in, and I'll do 2 extrudes. One's going to cut away that, and then one's going to add that little ledge in. So I'm just getting a nominal dimension here, and I'll do it from that. So 1.52, let's call it. So let's switch here, and then so extrude, and then 1.52. All right. Now the biggest question is what color is this going to be? I mean, if you had to pick a ubiquitous boss pedal, like, I mean, the SD1, the Super Overdrive, it's got to be it, right? I don't know. Comment what your favorite boss pedal of all time is. I'm thinking the Boss digital delay, which is funny because I used to have it and I got rid of it, but I think I got rid of it because I was very poor and a student at the time. But I don't know. My old man, I think, always had this on his pedal board, so it's kind of got a soft spot in my heart. We're gonna make this yellow because why not? That's pretty close to the actual the color I got here. Pretty damn close. All right, it's yellow now. Okay, so next is I'm gonna go sketch this. So like I was saying, we've got some kind of line that comes up here and then it goes like this. So I'm going to measure this distance here on the pedal. So I'm gonna measure that. Something like that. So then this is ballparky, right? 0.82. Let's call that. Okay, and then I'm going to measure this distance here. All right, this distance here. And I'm going to go. Enough. 0.23. We'll switch back. 0.23. Okay, and then lastly, I'm gonna measure this distance. And that is gonna be this way to do that. Okay, 1.57. Let's call it. Okay, we've got something like that, and then what is the best way to determine what that's? Oh, I can measure from here to here. No, that's not going to tell me that, is it? If I go. Actually, you know what? I'm going to keep this sketch here for a sec. I'm going to go back to my caliper cam and more or less going to center this about the frame. So here's another way we can do stuff. Measuring angles is kind of annoying when you're doing it in CAD. And that's pretty close. So I can just get the length actually. Let's just do that. Get this 0.32. See, what I was thinking of doing is just taking a screen grab of this and then just you can actually import an image to then like trace over if you wanted, but this is probably the better way to do it. I don't know, I'm just kind of rushing because I'm on stream, but if I stopped to think about it a little bit, it would have been a lot simpler. So we've got 3.19 there. So that basically is going to tell us everything we need for that. And then, yeah, so again, I'm going to do this in 2 extrudes. So I'm going to extrude this across up to the face of this side of it. And then I can make that sketch visible again. And then I can go for here and can extrude. And then I can remove up to next. There. So now we've got the basic bottom profile of that boss pedal all done. So what's next? Let's go back to this. So now what we need is like this top portion. So I might end up, I can take this screw out here. Yeah, so that's what's inside. It's our 9-volt would end up being. So when that is up, it isn't actually always horizontal. Like when you have the screw in, it's down a little bit. But yeah, so all I want to do is just like get this inner portion figured out. I think what I'll do is I'll get it pretty close to horizontal. So I think what I'll do is I'll just measure, like, say, I'm just eyeballing this now. So 0.42, so 0.4, and if I go here, that my absolute limit is 2.15 or 2. Call it 2.19. So I'm going to switch this over. And I'm going to go sketch on this. I'm going to take this, I'm going to project this down here. And then what I'm going to do is I'm going to do an offset. And then I'm going to measure what that offset is here. So on the caliper cam, let's go back to here. So 0.15 is how inset the edge of that pedal is. Is that pretty consistent across the whole thing? It's pretty close. Also remember, everything's drafted, right? Because this thing is all molded. So let's call it, between those three, I got 0.16 as my average. So I'll just go with that. Okay, so we've got that there, and then what I'm going to do is I'm going to extrude that, flip it this way, and then we're going to go up to this face, and then offset from that face. We're going to go measure our pedal here. So that's basically, like, I'm doing this as if it was a fully assembled solid model, so I'm more or less just looking for this. .2. Let's call it 0.218. So let's switch this back over. I'm not going to do this. I'm just going to do. Oh, sorry. Why did I say 0.218? 2.18. There you go. Oh, that is far, isn't it? I guess it is that far. So I got something like that. Let's do that. Let's give us a 0.05 inches of leeway here. So that's more or less what that is going to be like. And then I'm going to like sketch this guy. And we are going to take this, 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 and we're going to project that. And then I'm going to you know what? Let's do it the other way. I'm going to sketch on this. I'm going to project this. I'm just going to make that a construction line. And then I'm going to put this guy and over here, and then down like this, and then like, oof. I don't know if you can hear that being all jangly or not. Just one sec. Jangly or not. Just one sec. No, it's good. It's just Linux Pulse Audio things. Okay. Okay, so there we go. Now we've got the rough shape of that lid here. So if I switch back to, there we go. So I want to see what this ends up being. 0.7, 0.7, and then this one is 0.37. So let's switch that over. That's not quite right, is it? Yeah, it is. Oh. So I'm going to toss this screw back into my pedal real quick and just see what that looks like. And I might just measure the gap from the corner of that, or from the gap on either side. And then that's probably the cleanest way to do it. .11. And then we're going to go here to here. And what's that going to be? It's going to be 0.4. And this isn't exactly vertical either. So I'm gonna make, I can show my constraints here. So this says perpendicular to that. So yeah, now I have the freedom to kind of wedge that out. And I am going to eyeball that. Okay, so that I measured a depth there, 0.28. So if I go here to here, that's basically what I see on the Boss pedal there. So now this, I'm gonna get rid of that constraint. I'm gonna essentially call that that. And I'm not going to call it coincident. I'm going to call it parallel to this line. So, because I need to clear that corner. And that is closer to what I'm seeing. So we'll go from here to here. Let's just make that the same. That'll be clean. Okay, and then I'm just gonna quickly get this dimension here. .96. Okay, that's good. So now I'm going to extrude that up to face, over to this face, and we're going to merge that all in. There's our boss pedal. So that's the casement, and then I'm just going to make some knobs real quick. And also, which boss pedal is it? I'm just going to go with the 4-knobber, and then that'll be fine. So let's do a sketch, y'all. And what I'm going to do is I'm going to do this. I'm going to center this about here. And I'm going to put a point right here. And make that coincident with that. This point, I'm going to click on here, press I. That coincident, and then we more or less want these to be equal, so I'm going to make another construction line that goes from here to here, and then I'll make another construction line that goes from here to here. I'm going to click all three of these. I'm going to make those equal, and then you see we've got like an equal spacing of those knobs now. So I'm going to figure out where, well, let's find out what the diameter of these is. These are tapered as well, which is good stuff. So 0.465. So there we go. That's the diameter of that. And I'm going to make these equal. And then I'm going to measure this distance here. That's easy to measure with the calipers. And 0.127. Okay, and then this, actually I'll measure this to here and figure out what that is. Okay, so we got 0.62 inches. And that's where our knobs are. And so I think what we can do, yeah, we'll extrude this. I'm going to do a starting offset because these knobs are actually off from the pedal a little bit. So 0.11 should be good. starting offset 0.11. And then I can draft these as well. We're going to flip the direction of that draft. And then we're going to find out how tall these are. These are 0.74 minus 0.1. Go. And I'm just quickly looking at that draft angle just to eyeball it. It's not super important. Yeah, that's actually about right. Okay. And there's our nabs, and then I'm going to go and put the little check light in, because why not? .11, and then distance there is that 0.25, and then I made that centered. Cool. So let's extrude that. And that guy. I'm just going to do this with a quick little fillet. Doesn't need to be. Yeah. There's a little check light. And then lastly, I'm going to sketch on this, and I'm going to do this guy, and this guy. Cool. I'm going to figure out what this diameter roughly is. I'm probably going to have to take the thing off. 0.23. There we go. And then I'm going to extrude that through up to this face. Add, merge with all. Bob's your auntie. And can't forget our little screw here. So I'll just put this here. Figure out what that is. And that's going to be here. Okay, then next we're going to go and figure out where this is in relation to this edge here. 0.136. That's essentially like the shaft of that. And then I'm going to sketch that. And then I'm just going to put the outer diameter of that little knob, which is 0.414. And then I'm going to extrude that up to the height of that knob, which is ever so slightly rounded, but okay. The whole thing is also chamfered, so I'm going to add that in. 0.2, let's call that a 1/4 inch. Okay, and then I'm going to draft this thing. So, or sorry, clicked loft by accident. Draft is here. So the neutral plane will be this. So, and then what I'm gonna draft is that, and I'm gonna do it that way. Call that 5 degrees. Yeah, that looks a little off. 0.24. 0.25 is too much. Let's go with 2.1. There you go. Alright, works for me. Alright, so that's pretty good. So I'm going to rename this FX Boss. Okay, and then I think that can serve for the most part, at least for the kinds of pedals that we're interested in fitting on this pedal board. So let me take a look, see. Oh, we got some viewers. Say hello. Give me a chat or something. Yeah, so I'm gonna keep going. Let's go with a sip of coffee for starters. Okay. So we're gonna go with a new. Actually, we can put this in an assembly. So what am I thinking about in terms of how we want these laid out, right? So we'll have these pedals. So there's essentially like what I'm planning on doing is having a bar that goes across that is 3D printed, and I want to get the angles of everything correct. And I don't want it to be like a mile off the ground, but it's going to have to be some distance off the ground because I want to get my cables down through those bars and then under everything. And I want those bars to be like, remember, they're going to be 3D printed, so they can't be like really thin. And so that means I need to be able to get cables underneath or through them effectively. And I also want to have built-in cable management inside those bars that go across. So I think what I want to have going on here is figure out what a good distance would be based on the size of pedal that you might see someone put on here. So, because if I use the Boss as the way to do it, and then I've got Velcro that's like, I don't know, an inch or whatever, half an inch Velcro. Might not be enough real estate on this pedal if you go to like put Velcro on the back of this and then stick it on. So I'm probably gonna end up using this as a good limit between the spacing of those bars. And then I want this thing to have two layers essentially. So or 2 steps. So like if we go back to effects pedals. So the Planet Waves one, that one was the one we were looking at earlier, but I mean, this keeps coming up. This is ridiculous. Like, I don't need it to be like, and I that thing's gonna snap just looking at it. So they've got like a board and then another thing on top. That's kind of like the extreme version of what I'm looking at. This seems a little better. So this one is just, these are all planar by the looks of it. Let me look at this. No, I guess I can't. What is going on here? Let me go to this. Effect pedal boards. Yeah, I don't want it to be all flat. Yeah, like something like that. That's pretty cool. Okay, so this guy's making them himself or something. Constructables. So this one is like a woodworking project, but it looks like wood that's painted. But yeah, I like that this is like two-tiered. Whether or not it's also angled and two-tiered is kind of hard to say. But like this is more just like really shallow steps right here. Yeah, I'm just mostly looking to see what I like. Yeah, see like something like, so this is a 3D printed one. I think I've seen something similar to this on printables as well. They've got like threaded rod that went through the whole thing. Because that is definitely 3D printed by the looks of it. But I want my inserts to also be 3D printed, so then you can just get them in different lengths and just print them. That's basically what I have, with enough room for something to throw under it. So that'd be good if I was doing sheet goods, but I'm not printing sheets in plastic. That's insane. Yeah, I like this kind of appeal here. The spacing is crazy for that, but you kind of do need, like if you have these straight through cables, you do need some space in between them. So we can also get that figured out as well. I've got right angle ones, so 90-degree ones on mine, but that's okay. So let's see what we got. Oh, hi honey. I'm seeing your wave. So let's see what we can come up with for sort of a stepped pattern. So with this as essentially our building block. I should have probably added the jacks to this too, so I'm gonna do that really quick. Actually, I'm gonna steal the jack from this one, because that's essentially something I already got. So let's just do a quick split here. Where's split? Bat face. And then we're going to transform this. And we're going to go by mate connectors. I'm going to hide this. I'm going to move this guy here. I'm going to do it about this corner. I'm going to flip that. I'm going to copy the part because I still want it for the other guy. And then I'm just going to measure the offsets to where the centralized jack location is for that. So I'm going to switch back over here. And so I'm going from the bottom, or sorry, this back corner. This back corner is also ballparky, right? 2 inches. And then I'm going to go up by ballpark. Call it 1.1. 2 inches and 1.1. And that's where I'm gonna flip him. So this guy's gonna be moved. Okay, so we're gonna do that. And then I'm gonna transform this. XYZ. So minus 2 inches, and then I'm gonna go up. Okay, so that's what we got. Does that look like what we want? Yeah, I'd say it's not this one. So that's pretty good. All right, we'll go with that. Okay, so we've got that. And then in terms of where that is on the other side, it's not exactly straight through, but hell, let's just make it straight through. I wonder on the SD1 if that's there. Actually, on the SD1, it's... Yeah, it looks like on the SD1 they're both in this exact location, whereas this one ever so slightly off. So I'm gonna just mirror this guy. Mirror plane is gonna be this plane. Okay. And then I'm gonna Boolean this back together. Okay, so there's our effects pedals. Yeah, so let's go with the bar setup. So I think what we'll do, so what I'm picturing is I'm picturing like two plates. One plate on the side, one plate on the side, and then bars in between. So for our pedals that we're doing, like 4 boss pedals, so 2 on a bottom setup and then 2 up here, then I just can't quite decide whether they're gonna get stepped or not. The other thing I want to also consider is, like, I've got this power supply, so it probably is worth me doing the power supply really quick as well. Power supply is like a dead simple box, but I just need to know roughly like how big this thing is, and how far up the thing is going to have to be off the ground in order for different power supplies to have a place to go. So I'm gonna switch back over to this. So what I'm talking about is this guy here. And also, I remember this being really hard to get off. There we go. So I've got this guy here. So I think I'm gonna very quickly model this. Now, what's awesome with this is it already has like mounting holes, but that's specific to this. So when I make this thing, I don't want you to have to care too much about like what power supply you've got. Width wise, you're gonna have to worry about it, I guess. But like most of the ones I've ever seen are like, this is probably close to the tallest I've seen around out on the market that I've dabbled in. So I'm guessing if I can get my pedal board to fit that, my top to bottom, like, so this spacing, I don't think it's going to be much more than that, and I'm going to leave myself some room, because ultimately what I'm going to do is have it so that you'll be able to put a Velcro strap around your, so you'd have one here and then one this way, if you can make that work, and then so that way you can just secure it to the pedal board, but it doesn't have to be like a completely permanent thing or an extremely custom thing, which would be the locations of these, because God knows I don't think that they're like any standard on that kind of thing. So yeah, I'm just gonna quickly model that. So let's go. I'm just gonna also transform this to distance, direction. Let's call this 8 inches. Okay. I'm just gonna tweak this real quick. There we go. So now when I speak quietly, it doesn't cut me off with the noise gate. So yeah, we're gonna go and make power supply. So I'll sketch on this guy, and let's get our caliper game back. So 5.54, let's call it. And let's call that 3.45. Okay. And then, so we're going to do a quick extrude of that guy. And I'm going to quickly measure the depth on this. Normally that's 2 inches nominal. 8.6. Yeah. Might as well make it what it is. Okay, so, and then I more or less want, I want to be able to distinguish the front from the back on this thing. So what I'm going to do is just model in where the power adapter goes. So I'm going to quickly model the power adapter. 1.2 by 0.88. So, oh. Okay, and then I'm just going to get an idea of where this is from the side. So that is 0.57. And then we're going to go 0.17. Okay. And then I'm going to get my fillet gauge out. I'll switch back to this. And get my fillet gauge out and figure out what that is, just because I can. So that's 5 millimeters. And I'm just going to sketch the fillet on this. Okay, and then let's see, we've got roughly a, let's see what this is, 0.11. one 0.11. Okay, let's do that. So I'm going to do an offset. Yeah, and those are kind of rounded off too, so. Okay, and then I'm going to quickly 0.219. So it's got these okay, and then those are 45s by the look of it. Let's just measure this. That's probably the best way to go. 0.27. Okay. Okay. Get rid of this. Yeah, that'll work. We can do that. 135. Okay. There we go. So that's roughly what I want here. I'm going to extrude this. And I'm just going to quickly measure the depth of that. How far out from the sheet metal it comes. 0.0, let's call it 5. Okay. And there's my power plug location, and now I know which way is which. But and then I've also got some jacks on here. 1, 2, 3, 4, 5, 6, 7 of them. I'm just gonna quickly do something with those. Yeah, 1, 2, 3, 4, 5, 6, 7. So since that's an odd number of them, I can go with a construction line here, and then I can go make that coincident with that. I'm going to quickly get the measurements of this thing. .34 and 0.45, and then measure the distance to this edge. .32. Okay, so that's what we got there. I'm just gonna model in the barrel jack just a little bit. At least just the hole for it. 0.23. Measure this distance here. Okay, so something like that, and then what I can do here is, now that I've got that, I'm going to linear pattern, and I'm just going to measure from one corner to one corner. Figure out what the spacing of these is. 0.61. And then I'm going to take these guys and mirror them. Oops. And then mirror them about this. Okay. And then I'm going to extrude just going to extrude this out and remove that 0 point. I don't even know how deep those are. So I could look at one of these. They are 0.4. Something like that. There, that way I can tell the back and the front and more or less like, at least I know it'll work for an iSpot, which is like a pretty cheap pedal power thing for starters. But yeah, so that's more or less like the components that I'm gonna need on this like first board anyway. So knowing that, like this distance here to here, that's okay, so it's like 5.5 inches. Then that means I need at least that and then some for the like minimum width of the thing. So, and then given that like we've got this guy and this guy, that's like 3 inches. So yeah, like I'm looking at like 6, but then you also have to think about like there's gonna be cables in this thing here too. So you need some spacing in between. So we can ballpark the minimum spacing here with 2 pedals, and then I'll just shove some cables in here and in here. Oh, I guess that one has a 9-volt in it. So that's what we're looking at, right? And that's kind of where I spaced these. And I can't, and my calipers don't even go that long. I got a tape measure here. So yeah, now we're looking at like 7, just between those, because the thing is I can, when I go to print on a build plate, I got to make sure that the build plate's going to be big enough if I want to do these horizontally. Otherwise I got to do them vertically. So what is it, Bambu Lab X1, it's 256. So yeah, okay, so I could go 10 inches, but I'm gonna go less than that. So maybe 8 would be good. So maybe I can just take a look-see at this caliper cam. Hi, Mom. Thanks for watching. So yeah, so what I'm looking at here, that's like 9.5. So there's a non-zero amount of space between those. So 9.5 would be fine. So I feel like I could do that. I'd like to be able to have the freedom to print them horizontally, and the reason why is because I'm gonna be putting Velcro across them. So when you look at other pedal boards, think this first one here, yeah. So you've got Velcro going across all this like that. That's great. Yeah, this is that same 3D printed one from a different angle. So it looks like he bought like 1-buys or something and threw that together. That's actually pretty clever in terms of like materials spacing, but doesn't make it so you can just bolt them, because bolting into end grain sounds like a nightmare. But yeah, so we can do something similar to this. I would like to be able to print horizontal ones at least across on the printers I have. So 9.5 inches is probably okay. I can also make it, I want to have it so that I can have the rails go in to the end pieces. So the end pieces might have like a little inset section in them to accommodate those. But I want it to be able to accept connections from either side on every single one of them. So if you want another board, you can just, instead of having 2 of those like end pieces, you would just use this existing one, and then you can build on to that from there. But then you'd only need 3 of those sections. So those are gonna be non-zero thickness. So that may give you the additional space that you need to deal with this like horizontal stacking problem that we're trying to think about here. So if we got 9, and then let's say I did let's say I printed the rails like 9 inches. I really think 9 is a little overkill. Like I could probably go like 8.5, and then I can make those sections like 1 inch thick, and then I'd be able to stack pedals in between them. Anyway, we'll see it when it gets modeled, but so ultimately this is what this guy's going to limit how far apart they can go vertically before I start stacking them. I need at least the ability to put this and another one above it, and then I need room under the thing to accommodate this so that all the wiring's clean, and it's got to be able to stack 2 pedals side by side reliably. So those are my main constraints there. So what's the best way to go about doing this? So I think I need to think about the rail and the like the mating interface between those things. So I'm gonna actually make a new part studio here real quick. So I'm gonna sketch on the right plane here. So let's go and let's make us a rail. So how do I want the rail to bolt to the side panels? So I've got side panels and rails, and I need to make those. I like the idea of a through bolt going through a side panel into a rail. But if I have that feature, I need to be able to add on to it afterward as well. So yeah, and I want the rails to all essentially be in a line, but I want you to be able to add them on as you'd like. So what I'm thinking, maybe it's best to draw this. This is probably the easiest way. Just give me 1 sec. I'll switch over to here. We're going low tech today. Also, let me see who's alive out there. 4 viewers. All right, so yeah, we've got you can picture, I'm thinking it's going to be about almost like 1x, really. So I've got a rail here, and then I've got my section that I want it to kind of mate into. Whether I have top and bottom clearances to worry about is another thing. And then I'd have my next rail over here. So I need a way to be able to bolt this in place from here if this isn't on there. So let me draw an example of what that might look like without that rail there. So I want to be able to put, I'm thinking I can put a recessed section in here, or I can have like a countersunk feature. So whether it's a counter bore or countersink, I think a countersink would be better because then I can have more orientations that I can print this middle piece in. Because I can go up or down, like if I wanted to say print everything with like this being on the bed, I might be able to get away with that. And I can also, having said that, think about having this be chamfered so that I could print it and then have it bridge across. So that might be worth doing. Then also, if I countersink it, let's say it was a countersink feature, and then I've got like a bolt that goes into this, and then I've got my rail, and I've got a heat set insert or something is probably what I'll end up doing, and then that goes through like this. Maybe it makes sense if I show this like on end from this direction to have it so that I've got a hole here and here. I get a bolt, I get those in this way. I also need a way to get a bolt in through this way. So maybe I can have almost like, you know, like you'd have a pocket hole or something like that in the sides of this that I could get it in through. I'm not a huge fan of that. The other thing I could do, is there a way to use, there's a way, I could probably even put captive hex nuts in it. That makes sense. Because like I could make these have like a pocket hole feature on the underside. Maybe that makes the most sense. So I have a feature on the underside of this thing. So this is looking down from the top here. So if I had something that allowed me to get, you know, get an Allen key or a screwdriver into this thing, so you could put in a bolt here and then put in a bolt here, but not be super worried about its orientation. I could also have these, like the left side of this could be something that has that countersink feature. And then the right could have the ability to keep adding things to it. What's the best way to do this? Yeah, if I had the ability to stack these together and then bolt them together with or without this piece here, might be the best way to go. Hard to say. So let me think. So if I have, let's go back to this. So let's just make this simple here. Oops. 1 inch by 1 inch. I don't think I want to go much above that anyway. So what could I fit in here? I'll be going to McMaster-Carr in a minute, but let's extrude it this way. Let's go 4 inches that way. Okay. And then if I were to then oh, that would be cool. Okay, I think I got an idea now. So let me do me one of these. So say I've got this going on here. Put this guy through there and there, like this. Yeah, so if I had maybe not 45 though. Maybe it's more like 30. Oh, sorry, 60. So I have something that I can throw a bolt in through this way. And then I could have these bars be rotatable. And maybe I make this feature part of the inner wall thing. I want you to not have to ever take apart the old one to add features to add to the new one, or to add new pieces to this thing. So if I just extrude this out to here, for example, I switch out to the face here, and then I got okay, so I've got something like this, right? And then I've got something that goes through like this. Let's just do one for now. And I'm just going to use like simple memorizable things. So let's do a 1/4 inch. My hardware won't probably end up being that robust, but yeah. And then I don't know what this distance is because now it's 45, so without doing any trig, although I can do it. I have the tattoo to back it up. Yeah, let's just go with this. This would be mathematically correct. Through this. Remove. Let's just do through all. Yeah. Okay, so that's what we've got there. So that might not be what I want for angles. So what? That's like tricky to get anything in. That will strengthen this part, because you'd have like these extra walls and stuff in the thing. And granted, I wouldn't have it look like this. But I could be able to like get, so let's say I've got this piece here. I've got another piece that, let's go and mirror this thing. Maybe not a mirror, so let's transform this. Let's do this one. Translate by, we're gonna rotate this. Rotate it this way. And we'll do it 180. No, maybe I just want to mirror it. Hold on. Let me just mirror this. Mirror this guy about this. Okay. I don't want to add to it though. It needs to be a new part. And then I want to transform, rotate. That. Okay, and then I want to move that. Oh man, no, that's not what I want to do. Here, one sec. There we go. Okay, so we have our single part, and I want to transform, make connectors from this make connector to, this is the entity, to this make connector. Flip. No. No, that's not what I want. I just want to take this, rotate it, and move it over. It's probably... yeah, maybe that's what I will end up doing. I just want to rotate this, move it over. So transform, we want to take this guy, transform by make connectors. No, rotate. The axis of rotation is going to be the centroid of this thing, which I can select here. I'm going to go 180. Okay, that's good. Copy part. And then we're going to go not this main connector. That main connector. This is painful. Okay. I don't know, I'm just drawing a blank, man. I'm just having a hard time. Let's see. We can go... Yeah, let's just do that. Transform. Perfect. Okay, so I've got this going on. So that would be, yeah, I would need a different kind of, okay, so yeah, I could have this bolt into that. And then if this was, let's say, moved over, transform this guy, transform him by distance, this direction. Half an inch, let's say. Something like that. Now imagine maybe this is a little closer to the parallel with the thing. If I have my middle insert piece that would go in between these rails, so this would be the rail for like the dividing line between the actual like sections of the pedal board would be somewhere around here. Then I'd have the ability to put a bolt, because I just don't want any of the heads of any of the bolts to be showing on the top, because I need a side, one or both sides of this thing to be able to have Velcro going across it in order to be able to stick the pedals to it. But I also need to make sure that, like, so if one side is angled like this, the other side would actually be like the same sort of thing, but you would have a flat face like that. So it'd be more like a parallelogram sort of situation. So one goes to the left and then one goes to the right, and then I make that thing in between. You're able to then on the short side, so this side here, like on this side I'd be able to put a bolt or a heat set insert into it, like into this face that way. Or I could, like on the bottom side of this thing, so where you won't see it, I could put an insert to be able to put a nut in there and then just push it in, and then that would make it really cheap and less time consuming, I think. Because if I sell it as a kit, I could also just give you all the hardware and then you could easily assemble it if you want it to be cheaper. And then that would let me then put a bolt through, let's say, I could put it in through the plastic of this, and that would like allow this thing to cinch into that and find its way home and be pretty sturdy. And then I also have the ability to inside either this part or the next part have the ability to embed a nut inside the actual outside of this piece. And then let's say you wanted to add this guy on, well then I guess you could take a bolt out of here, and then you'd be able to take the nut out of this section of the middle piece, and then have it kind of just go through into this next guy. Does that make sense? Because I could then have like I could have the nut in this, or I could have the nut in the other guy. But I want if you're gonna daisy chain these together, I want this and this to sandwich that thing in between. But if you're not gonna daisy chain these together and you're gonna have this be the end of it, I want this to be able to bolt into that as well. So and I want it to be easy to get them in or out. That's why I have this angle here, because then you'll be able to hide the heads of everything, so you don't necessarily see it all. And then I don't know, you might be able to do something cool with like that as the feature of the thing. So it might come down this way and go jump. It might look kind of neat, like lightning bolt looking thing or something, you know. So anyway, I'm gonna give this a little bit more thought. I think I'm starting to run out of steam. I need to stop focusing for a minute. But yeah, so basically on this stream we got our building blocks for like where we want this all placed. I've got a rough idea of like how I think I might end up bolting this together. Took a look at some of the existing things that are already out there that I might want to be competing with, and what can I do that these aren't doing, and make it a little more like they're addressing the scalability problem with VEX boards by having this slidey bit, which is great. This is like you're kind of locked in, but you got a decent case, and they've thought about like trying to make it so that there's good cable management, or at least some cable management like baked into it. So I want to be able to do essentially both. I want to be able to expand mine and add to it later, and I want to be able to have like built-in cable management features into it. I guess this one also has that, but yeah. But have it in such a way that's like it's just Velcro, so it's like dead easy to get everything to mount. So I'm just gonna like brainstorm a little bit after the fact, come up with a good mechanism for putting this stuff together, and then from there I can we can start catting up the rest of it, and we'll do that in another stream probably. So anyway, that'll be it for today. Again, give me some feedback if you're a serious viewer and not just, I mean, granted, thanks honey. My wife and my mom are apparently watching, or at least have watched, so that's nice. But yeah, if anybody is like interested in the design aspect specifically about this kind of thing, then if you have any ideas, like point them out in the comments or whatever. Anyway, yeah, that's it for today. So we'll see you on the next one. Bye.